Okay, we're going to begin probability. So this is page 72 of the note spiral. This is just the introduction to probability. Probability is probably the most difficult subject for most of my students. About 25% of the students say this is their favorite, and then the rest say this is difficult. Please pay attention all the way through. You're probably going to need to come back and watch this video again just to make sure you know everything. So probability is the ratio comparing what you want to happen to the total number of possible things that could happen. So it's your number of favorable outcomes over the number of total possible outcomes. Or sometimes we refer to it as what you want to happen versus the things that could actually happen. As we've stated before in previous videos, the probability of the impossible is 0 or 0%. The probability that it's guaranteed is 1 or 100%. There's no such thing as a negative probability, and there's no such thing as a probability greater than 1. So they all range between 0 and 100% inclusive. Random phenomena is possible outcomes are known, but the outcomes for a particular event is unknown. So it's just not things that randomly happen. When we talk about random phenomenon, is we talk about like flipping a coin. We know that a heads or tail is possible, but every time we flip the coin, we have no idea what's coming up. So that's the randomness we're talking about. I want you to put a star by sample space. This is a super important thing. Sample space is a list of all possible outcomes. And this is not an important thing just because I want you to memorize the definition of sample space. It's because I actually want you to go make a list of sample spaces when you do a problem. I know that my students tend to score very well when they take the time to actually list all the possible outcomes. It increases their scores. A trial is just a single event. So basically it's like rolling a dice or spinning a spinner. All of those counts as trials. So every time you do something in a probability manner, that is considered a trial. Law of large numbers. The law of large numbers says as we do something over and over and over again, the actual what we actually observe gets closer and closer to the theoretical. So if I flip a coin, theoretically, half the time it should end up heads. But if I were to flip it 4 times in a row and I got 3 tails and 1 head, you're like, well, that's not 50%. But it probably wouldn't bother us that much because it's not that unusual. But if I were to flip it 4 million times and 3 million of them were tails and 1 million was heads, something was off. So if I flip it 1 million times, it's going to be really close to 50%. It might be 49.9997 or 50.001. But it's going to be extremely close to 50%, so close that we say that it's 50%. So as we do something over and over and over again, what we actually observe approaches the theoretical. Do not apply this to an individual trial. In other words, when I flip a coin and it's not 50% heads, it's just one trial, that's not enough. But if I have a lot of trials, then it should be a very good estimate. Also, do remember that the past does not impact the future if events are independent. So what are independent events? Well, previously we talked about independent events, and we did say that the past did not impact the future. So if I had 5 heads in a row, there's still a 50% chance that the next one is heads. Why? They're independent. The past did not impact the future. So when we talked about it previously, we talked about independent events as being proportional. We also talked about the fact that when we were working with segmented bar charts, that if we had 2 bar charts, 2 bars, that the corresponding segments would be equal size if events were independent. Here we're going to add something else. We're going to add the multiplication principle. Keep in mind, the multiplication principle is only the case if events are independent. So if events are dependent, we can multiply them. And I know you've been multiplying them since in middle school because the events were independent. So in this case, here's our little saying: the probability of A intersect B. This little symbol is the intersection symbol. We also refer to it as the and symbol because when we're reading it says and. We rarely say intersection. The probability of A intersect B equals the probability of A times B, or the probability of A and B equals the probability of A times B. Do not use this unless the events are independent. In other words, you can't multiply events unless they're independent. In probability, or means add, and ands means multiply. These are just big hints. Probably want to put a star by that to make sure you keep that in mind as well. All right, so let's look at some very simple problems to get us started. A fair number cube is rolled and a fair coin is tossed. Remember, a number cube is just a six-sided die, and of course you have a fair coin. Well, let's write down the sample spaces. So the sample space for the number cube is 1, 2, 3, 4, 5, 6, because that's all I can get. And for the coin, it's either heads or it's tails. It's quite that simple. What is the probability of 3 and getting a tail? All right, so we have two events here, and I find that it really helps to make blanks so I don't forget what it is I'm talking about. So the probability of 3, well, there's only one 3 out of the 6 numbers, so the probability of a 3 is 1/6. And the probability of getting a tail, there's only one tail out of 2 possible outcomes, so this is 1/2. They use the word and, which means multiply if they're independent. But I'm going to say that rolling a dice does not impact flipping a coin. So I believe I can multiply these. They're independent. So we're looking at 1/12 as my solution. So now we have the next one. What is the probability of rolling 2 4s in a row followed by tossing 2 heads in a row? Well, once again, I like my blank method. So I have 1, 2, 3, 4 blanks because I'm doing 4 different things. Well, the probability of rolling a 4, looking up at this, I have 1 4 out of 6 numbers. So this again, 1/6. But I'm rolling 2 of those, so this is also 1/6. Followed by tossing 2 heads. Well, a head is 1 out of 2. And even though they didn't tell me, they didn't use the word and, I can infer that I need to be using the word and because I have to do 1 4 and a second 4 followed by and a head and a head. So I have to do a 4 and a 4 and a heads and a heads. So I need to be multiplying these. And when I do that, I get 1 over 144. What's the probability of rolling a 5 or a 6 and then tossing 3 heads in a row? So we want to roll a 5 or a 6 and then tossing 3 heads. Well, first off, 1 5, 1 6, and then 1 2 3 heads. Well, we've been talking about the heads, so let's do that first. So actually, we'll just go back. First off, the word or. Be careful. We know that or means add. So I'm going to put the addition sign right there so that I remember to add. And we know the probability of a 5 is 1 out of 6. We know that the probability of a 6 is, there's only one of them, so 1 out of 6. Anytime I say add, go ahead and put those numbers in parentheses, however many they are. It'll help you out with order of operations. Then the probability of a heads, we know that there's only one head out of 2 possible outcomes. So 1/6 plus 1/6 is 1/3. I multiply all the way across. And this is about 1 over 24. Okay, the next one. A bag contains 3 A's and 5 B's. So we have, my sample space is A, and then B, 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 B. What's the probability of drawing an A, all right, rolling a 6, and then tossing a tail? So we're doing 3 things. There's the A, there's the 6, and here's the tail. The probability of an A, well, 1, 2, 3 out of 8 possibilities, so 3 eighths. Probability of rolling is 6, 1 6, and we need to get a tail. All right. Equals 1 over 32. And by the way, I probably should not have started off by reducing that. I prefer that if you didn't. So I probably should have started off with 3. I'm going to draw a line, put an X through that real quickly. 3 over 96, which is 1 over 32. What's the probability of drawing a B and getting a heads on the coin and either a 2 or a 3? So we're going to get a B and then getting a heads, and then we have that or, so we're going to put a plus sign because we're adding 2 numbers, and it happens to be a 2 or a 3. Probability of drawing a B, 5 out of 8. Getting a heads is 1/2. A 2 is 1 6, and a 3, there's only 1 3 out of 6, so 1 6. All right. And I'm just going to leave that one just like that. I will continue with probability into the next video, but I wanted to break them up so they wouldn't be too long.